Hey everyone, this is Sada Waziri, and today I am here to introduce another interesting deep learning project, which is Bitcoin cryptocurrency price prediction using the deep learning mechanism and architectures, like we are using recurrent neural networks architecture called long short-term memory. So let's get started. Before going to the practical part, I'd like to briefly explain the Bitcoin and also the LSTM and RNN. So Bitcoin is a form of electronic cash, which is the world's most valuable and the first decentralized cryptocurrency that can be sent from one user to another on the peer-to-peer Bitcoin network without the use of intermediaries. So a database framework called blockchain, which is similar to an encrypted registry with Bitcoin transaction, secures and keeps track of all Bitcoin transactions. And since the features of Bitcoin are so complex and its prices, its price fluctuates over the time, like very quickly, as we can see in here, it's for this is a real-time data visualization of Bitcoin cryptocurrency prices. So we can see in one day, hourly, the prices is changing. So, and also if we see from the 2017, it's really rapidly changing and it's fluctuating, so it's really difficult and complex to easily forecast these values. So there are only a few algorithms that can predict the value of Bitcoin cryptocurrencies. And also, in order to greatly support today's investment decision, it is necessary to accurately forecast the value of Bitcoin. And as the prediction of Bitcoin prices falls under the time series prediction category, so deep learning mechanisms and neural network models can be considered, can be highly considered, especially in such data which are temporal in nature. So, and also we are using the LSTM, which is an architecture of a recurrent neural network. It is the most efficient and well-known artificial neural network mechanisms which are designed to identify patterns in data sequences, such as like numerical time series data and like cryptocurrency data and stock markets. So let's get into the practical part. In here, I have created a Python virtual environment because with the version of 3.6, because if I use the Python version more upper than the 3.6, so it would give like some inconsistencies between the TensorFlow versions and Python. So that's why I have created a virtual environment. So I am now activating it. So activate, it is done, and now I'm running. I have two files. We have two files, which is prediction.py and preprocess.py, which in this file we are pre-processing the data for the model, and in here we are defining our model and training it with the preprocessed data. So let's run our file. Yeah. The dataset which we are using for evaluating our model is a real-time Bitcoin cryptocurrency from December 2015 to current date, which is the 3rd June of 2021. So in the total of like 2001 days of financial data. And during this period, we can see that the lowest price is on December 2015 and the highest price is on April 2021. We can also see it in here, this one and this one. So Yeah, so let's see our data set. This is our data set. We have 8 features and 2001 rows, and among these features we're using the close price or close feature for predicting our predicting the prices, and this is our target value. So and also as the data on LSTM model requires to be in the form of sequences of like x's and y's, so we have to like define time steps. Like in this case we are using a time steps of 30 days prices, so the x's values will be the 30 days prices and the y will be the 31st days, which is the next day price that we are going to predict. So in order to as our model is built on an RNN with LSTM layer, so some data preprocessing methods like normalization, transformation, and reshaping is a must. So we are at the first, so as I said, the LSTM layers transform input vectors into vectors with entries in the 0 and 1 range using the sigmoid activation function, because this because the denominator will always be greater than the numerator. We apply normalization to scale model features, so the output value will always be a number between 0 and 1. So as we can see in here, this is our real data, and then this is our data after the normalization, which are the values between the 0 and 1. And also we, as I mentioned, that we are make our data in the sequences of 30. So this is a sample of one sequence. This is the 30 sequences, and this is one value, and this is the x train, our x's, and this is the y train, our y's, that we are predicting this value, like not this value but the y's, which are these. So and after that we are splitting our data into the two sets, the training and the test, so with the ratio of 80 and 20. So and after that, as the RNN LSTM requires the data to be in the 3-dimensional format, so we have to reshape our data, and we get a shape like this. So which 1571 is the number of samples. Like this means that in the training data we have this much examples to learn from, and this one means that with each example looking back 30 steps in time, such as what the stock price was yesterday, the day before yesterday, and so on until the last 30 days. And this is what we call it a time step. And the last number is represents the number of features, and here we are using one feature for prediction, so we are taking just a 1, and this is the shape of our x train or train data, and this is our test data. So now let's go get into our model. Let me comment this, uncomment this part, and comment this one, and let's run our file again. Now we are training our model with the data, with the pre-processed data, so it might take some time. Until then I'm stopping the video and we'll get back. The training of the model is finished. Now we can see that we have gained the accuracy of 95% and the root mean squared error of 0.06. It means that we have quite a good result. So let's see this one. This is the visualization of our prediction. This is the train data, and the yellow one is our test data, and this green one is the prediction, which is quite matching with the test data, as this one is not is not sticking with this because it's not 100%, so that's why it's normal. And also we gained this one RMC, and so this one is the prediction results that are the action and the predicted. So for example, we are getting a really good accuracy and a really good result of predicting the prices. And let's see the model architecture. We have two LSTM layers with the hidden nodes of 50 and a dropout layer in order to remove the overfitting, in order to prevent the overfitting and for the sake of regularization. And also we added a dense layer, which is the output layer. So this was our model, and this prediction. So one another important thing, that there are two important points of creating a model for the Bitcoin prices prediction, is that properly we should pre-process the data, and the second one is the properly tuning the hyperparameters. For example, we are using like batch size of 19 and the epochs and this learning rate. So we gained this values experimentally, and we tried so many different values, and finally we get a values which is quite satisfying. So it is really important to focus on these two things. And also we compared this model with some existing methods, such as another RNN LSTM models and MLPs, RMSE, and so on. So this comparison revealed that using the LSTM with proper hyperparameter tuning is one of the most effective methods for predicting the Bitcoin process. So this was all about this project. So hope you enjoyed watching the video. So thank you so much.